Welcome to solverfy.
Question number 24 can be a little tricky if you're not careful. So the first thing you want to do is set up your problem. So I've drawn the wall here and some distance r, which is equal to the radius of curvature of this spherical mirror. You place an object, which is here. And the question wants to find at what distance should the mirror be placed such that a real image is formed on the wall. Well, if we know that r is our radius of curvature, we can get the focal length from that because it's just the radius of curvature divided by 2. So we have that written down here. One other thing that we know is the object distance. Well, sorry, I should say the image distance is going to be the distance from the wall to the mirror. So that's di. And then finally, we can say that DO is simply going to be equal to DI minus R, because this distance is R, and then if you take DI minus that, you get our DO, which is here. So, like I said, it can be a little tricky, but once you get it set up, it's not too bad. Now, if we want to solve this, we use the standard equation for these types of situations. Oh, far too many equal signs. And you can plug in for R and plug in for DO. And finally, we want to find DI, but sadly, we can't really solve for that because we simply have something in terms of R. So we're going to have to get a solution in terms of R. Rearranging this, we can write that 2di squared minus 4dir plus r squared is equal to 0. We can solve this using the quadratic equation. And di, 4r plus or minus, blah, blah, blah. I'll let you do that part. You get r 1 plus or minus square root 2 divided by 2. However, we're only going to want where the image distance is greater than r, so we're only going to look at the plus side of this thing. So because this could either be less than, this term could either be less than or greater than 1, and we want the one that is greater, so it's going to be plus. So we get that di is equal to 1.71r. And it wants us to calculate the magnification, sort of as a little bonus at the end. And that's not too tricky because we'll go to a new page. M is simply minus di over do. And we have that our di is 1.71r, and do is just di minus r. So 1.71r minus r. The r's cancel, and the magnification is minus 2.41. So it is bigger, but it is inverted.